Hello friends. Today, welcome you all. Myself Ritin Bahal, Assistant Professor from ABES Engineering College, for the lecture series of DBMS, subject code BCS 501, the important unit, the unit 4, the transition processing concept. In the last lecture, we have seen that if we have a given schedule, how we can check whether a schedule is a complete serializable one by using the precedence graph. Now, once we are done with it, if we get a cycle, you need to move forward because after making a cycle in this part, in the loop part, we can't guarantee that it is a serial schedule or not. The serial schedule or the given schedule exists or not. Whereas if the cycle doesn't exist, we can 100% sure that it's a conflict serializable and we can find the serial schedule by the conflict serializable technique. Now, what is a new technique after the cycle doesn't goes for the loop part? Means there is a cycle exists. So after this thing, we have to check for the view serializable. So the first thing is we need to check for conflict serializable. And if cycle does not exist, we can say that it is conflict serializable, yes, and we can find the serial schedule by using the topological sorting. This we've already discussed. Now, if it fails, if cycle exists, then this method fails the conflict serializable. That is this is precedence graph. Now, what I have to do is after this thing, I have to check for the view serializable. So let us discuss about a very important concept, how we can assure that a given schedule is a serial schedule exists or not, that is by the view serializable. So what we have to do is, a view serializable is a long method, but it's an easy method also. We have to go through and check for the each step for all the kind of the possible combinations. So we need to check for all possible combinations. So if we have two schedules with 3 transactions each, so total number would be 6 combinations would be there, and we need to check for the each one once again, making that this one is a view equivalent. If it doesn't exist, we have to find the another one is a view equivalent. Now, what is a view equivalent? Now, this is our concern. A schedule is called as a view serializable if it is view equivalent to the serial schedule. So what we are going to discuss is and find it out. We need to find a view equivalent of a serial schedule. Now, how do we find a view equivalent? Now, if we have two different schedules in which we have n number of transactions, now what we have to look for the data item. There can be one data item, there can be two data items, we have 3 data items, but we need to look for the important point is same data item. Same data item. Okay. So we have S and S1, and if we have T1 here and T1 dash here, they have read A and read A. So this is there, something like this. So what I'm talking about, this kind of a data item. So what we need to find out, the first we need to find it out initial read. So let us see about two schedule S1 and S2 are set to be equivalent if they both satisfy the following conditions. So for S1 also we have to cross check, and for S2 we have to cross check. And if both all qualify all the 3 conditions, there are 3 conditions: initial read, update, and the final write. Initial read, update, read, and the final write. If they follow the same thing on S also and S1 also, then we can say that S and S1 are view equivalent. And after that, we can find it out for a serial schedule for it. Okay, so what initial read is, any kind of a data item, initial read on the both the data item must be same. So if this is there, it should also be in this part. Now, what is an update read? If in schedule S1, for example, S1, the transaction T1 is rated item by the T2, then in schedule S2, T1 should also read the value of T2 write operation on the same data item. Okay, let us see the final one. So we have, what is the final one says is final write. Now what a final write says is last write should be there on this thing. So we have initial read, we have update read, and we have the final. Okay. So let us see initial read. What example says is these are the three conditions. So if schedule S1 is read A and write A, so even in the schedule 2, we have read and write A in this order. Okay. So what is an update read? For example, T1, T2, T3 is there, write A is there, write A is there, and read A is there. Similarly, write A, and the read A. So this, the order of the read and write should be there. So first we have a write and then we have a read, that is the read update. Final write, write A, read A. So who is doing the last write? That is T3, and even in this is T2. Similarly, final initial read was in T1, and similarly there is the T2. So these are the condition we need to check. Now let us check an example and find out whether how we proceed for a V equivalent or not. Okay. Now let us take this example. We have an S and we have S1. Now what are three transactions are there? So we have 6 factorials, 6 for the S1, S2, S3, S4, S5, S6. So we have to make for each one check, and we need to check one for compared to the S1. Now what we have taken S as, what would S1 would be? So S1 says that T1 should be occurred first, T2 should be occurred first, after that and T3. This we assume, and this we need to check with the original S schedule. This is first. If it is view equivalent, it's okay. Else what we have to do is, we have to make S2. Now what an S2 says, T2 execute first, T1, then T3. This we assume. Then S3 would be what? T3 occur by T1 by T2. And similarly, all we have to check. So we have to check each one by one. Okay. So what an initial read says is, now if you see that in T1, this S schedule is there and this S1 is here. So let us make initial read in S and in S1. Who is doing it? Okay. So read is done by T1, and similarly in S1 also, initial read is done by this thing. Now let us talk about the write, final write. Let us talk about a final write. Final write is done by T3 here, and final write is done by T3 here. So S by S1 is T3 and T3. Now if you see that after rewrite, there is no read operation. There is no read operation after the write. So there is no update also. So initial read is done by which one? T1 and T1, and final write is done by T3 and T3. So what we can say that this is a view equivalent. Thus, S is view equivalent to S1, and we got an answer. And what is a serial schedule is? This is an answer that is T1 followed by T2 followed by T3. If this fails, we need to go for S2. Again, the same process. If it fails, we need to go for S3 and the same process. Then we need to go for S4 and the same process. Till this thing. All the view serializable schedule are conflict serializable schedule. Make sure this is a very, very important point. This has been asked in very kind of competitive questions. Every view serializable schedule is a conflict serializable, but reverse is not possible. Means 100% assurance is not there. So I hope now you will be able to solve the questions. Let us talk about a new features, that is the recoverability. Now we know that all the transactions got failed due to many kind of things. We need some recovery procedure when the system restarts. Now we know that transaction also fails due to hardware and software. So we need some methods for that, to restart, to reboot, to restore somewhere. In this section, we are dealing with the recovery of the failed transaction in the two broad areas. So we are talking about which transactions which failed, and failure can be active due to any kind of a thing, the software part, hardware part, any kind of a thing. But how do we deal with the failed transactions? When a transaction fails after entering the partially committed state, this is the first phase, where dependent transactions may lead into the situation where recovery is not possible. So there are some situations where recovery is not possible. There are some situations where recovery is possible. And we can deal this with the two methods. You'll see that failure during the partially committed state. Now, what is the important point is failure due to the partial committed state. If a transaction fails after entering into the partial committed state and values are either reflected or not on the stable storage. So means that we have not finally updated in the database values. It's there in the buffer part. We've already seen that transactions after the word commit will proceed from the buffer value to the final database state. Okay. So if it happens a transaction fails in between this thing and before the commit word, then it can be do something. It can be done something. So what is there is this can be done by implementing atomicity and the durability properties. So these two properties, the asset properties, shows that this doesn't happen, and if it happens, how we can prevent this thing from the inconsistent database, and we can make the concurrency. The DBMS component that ensure atomicity and durability is called the recovery manager. We have the two shadow page in the log page. So in the next lecture, we will be discussing about different kind of schedules when the transaction fails. Like recoverable schedules we have, some are irrecoverable. There are some situations where the data has been lost, the concurrency cannot be achieved, and we say that these are the recoverable or irrecoverable schedules. There are cascading schedules and the strict schedules. Now, these are very important points when the transaction goes at some state before the word commit on these things. I hope you have learned from the today's lecture. We have seen about how do we achieve the view serializability, which ensures that whether a given schedule can be executed in a serial order or not. And the 100% give you an answer with that. We need to find the view equivalent. How do we find the view equivalent? Is initial read, update read, and the final write. Then we have some transaction which fails. If it fails, we can recover it or not. If it isn't partially, we can still recover it. How do you achieve that? By the asset properties of atomicity and durability, by shadow page and log based recover. In the next lecture series, we will be discussing about cascading schedules, recoverable schedules, irrecoverable schedules, cascadeless schedules, and the stick schedules. Hope you have learned from these lectures. Thank you all.